Okay, this is going to be César. He's going to be presenting on so you want to maintain a Python legacy code base. Take it away.
Thanks a lot. Hello, everyone. My name is César. The title is So You Want, because I think you don't really want to maintain a code base. The first thing I want to do is I want to ask, please raise your hands, those of you who have been in this business of software development for less than a year. Less than 5 years? More than 5? Okay, it's a good bunch. So yeah, I live in Switzerland. I'm from Mexico. So let's hope we understand each other. I've been using Python for a while, and I'm co-organizer of the equivalent to the Pycon Switzerland. So if you want to visit it, please be welcome. This is what we are going to discuss today. A short intro and then a quick survey of 3 points of a little framework. So why discuss maintenance? If there's a single reason, it could be because of money. Because according to several studies, organizations and companies and universities and so on, they spend up to 80% of the money that goes to software into maintenance. So let's say you want to learn about computer programming, and then you go to Amazon and search for books. You get 200,000 results. That's a lot. What happens if you search for software maintenance? It's much less. And then what happens if we go deeper? Like the top 4 results, it's software maintenance, and then the 4th is HTML for dummies. This is real, like seriously. And then, Google suggests is often a good indicator of what people search for. And then if you search for software programming, it's why is it software programming easy? And then if you search for software maintenance, then it says, why is it difficult or costly? So you get an idea of what kind of trends we have here. So I was feeling really curious how we fare as an IT industry, how we fare against other industries. For instance, the car industry. The last time I got a brand new car, I got a warranty of 5 years or up to 100,000 kilometers. And I guess you can drive it up to 200,000, I don't know. But that's like 40 years maybe. I don't know. I'm using Thomas the Tank Engine because I have 2 children and they love Thomas, even though they are not in England or in UK. So I met somebody from the Swiss railway company, and he was telling me a really good story about the system for the tracks in Switzerland. And they have a provider, and they have two different maintenance cycles for these systems. The new one, which is based on electronics, it's a short one, and it's got only 80 years support. And the long one is 150, and it's totally mechanical. So how we do as IT industry? I was researching about really old projects like the Linux kernel. It's 25 years old already. LaTeX, a little bit more than 30 years. And there was this system from the US Treasury Department, which is slightly more than 50 years old. And there are probably many Fortran or COBOL systems out there. And there's this joke that nowadays COBOL programmers are not really hired because of the years of experience they have, but because of their life expectancy. So my record in this regard is 4 years. The longest product I have maintained, and then it died, it was for 4 years. I don't know who's managed to make it 10 years. Wow. That's a big achievement. So here's my personal view of software maintenance. We have a saying in Mexico, you want the ruffle of the tiger. That means you got the ticket, you got the winning ticket for something you don't really want, something which is dangerous for you. You don't really know what to do with it, but anyway, you have to take it. So this is a bit of my life as maintainer. You know, when I was much younger in Mexico, I saw quite some dirty code, and I thought, well, maybe, you know, we are third world, and then we do bad code. And then I was really excited because I got a job with an American company, and then I was thinking, oh, these guys have to have really awesome code because it's first world. And then turns out it was a horrible system. I had the core of it. It was a class which was 3,000 lines long, and it was mostly a huge switch statement, like really. And then I moved to Switzerland, and then I assumed I was stupid. I think I assumed that everyone was doing just as they wish or as they felt, and then turns out the Swiss pride themselves on their quality, and I experienced some not so good moments. But then I learned basically it's different in each organization. So there are some good teams, some bad teams. So I came up with this little framework for maintaining software. The first one is before you touch anything, understand. You know, sometimes we engineers tend to focus only on technical parts, only on the code, but it doesn't really live in a void. You know, normally software has a business reason to exist. There are users, there are people paying for it. So that's the idea. You need to understand why, what's the financial reason to get this software in place. You need to, if you can interview people, especially the power users, which are really a very important source of input. Check the use cases or write if you don't have them. You need to see why everything is in the place it is, like why things are deployed the way they are. Maybe create some diagrams. What I do sometimes is I need to think a bit out of the box. So I pick the most important parts of the code, I print them, and then I make notes and marks and so on, and it helps me a lot. So maybe you can explain it to somebody else, to your grandma, to a rubber dog. I don't know, it helps a lot. If there's any documents, be sure to read them or write them. And there are really good Python tools for that, docstrings, doxygen, Sphinx, and so on. Debug your system, not to fix it, but just for the sake of it, to understand, because there's a static part of the code, but there's a dynamic view of it, and you can benefit a lot if you see how things move based on which input. Same goes for, well, there are really good tools. My favorite one is beautify, but my team uses IPDB. Same goes with profiling. Don't fix anything until you are sure what you are doing, but just try to understand what's going on. There are really good tools like cProfile, TimeIt, Hippie, memory profiling, and so Then you need to break your system. You need to know how well or how bad it scales. What breaks first? I mean, it's important to know if it breaks with 2 million concurrent users, but maybe you are never going to have such a number of users, so at the end it may not matter. But if it does, then how would you recover? And it's important to know these things. And Python has really good tools like Nose, pytest, and there are some non-Python tools as well, like Apache Benchmark, JMeter, Locust, and so on. Second part is build yourself a safety net. Sometimes the only thing you need is once you do a change in the code, you need to see smoke coming out of the computer to see that something broke. And this is especially valid for code that you didn't write yourself, and then maybe you cannot trust. So do a lot of tests. They're going to help. And you have really good Python tools as well. Nose, pytest, coverage, Selenium, docs. There's also the canonical build, because sometimes we have this saying like, it works on my machine, but not in the others. But we are not shipping my machine, right? So there needs to be a canonical build. Everyone commits there. If anything is broken, it means it's not safe to release. You need to do some continuous integration to make sure that there is not a big bang. I mean, this was more common like in the 90s. I remember those projects when we had we didn't really have a GitHub or Git. And then at the end of the project, there was a big bang because the interfaces changed and nothing was as expected. In my team at the Web Republic, we use Jenkins, and it's really useful because we get a notification when the build is broken, and even better, we have Git protected branches. So if the build is broken, we cannot actually merge anything. So that's really a good safety net for us, because we make sure that every test passes before we release our product. There's also some monitoring needed, like upbeat. Sometimes, especially when it's code that you inherited that somebody else wrote, there are 100 of errors and mistakes and failures, and sadly you cannot fix them all. But at least you can get the statistics on what's failing the most, and then address the specific part, like the most common or the most critical. You have also visualization tools like Logstash and Kibana. I don't know if it's really visible, but basically you need to look for patterns, like anything that goes outside the common patterns of behavior of your system is a red flag. Automate as much as possible with tools like with deployment tools or provisioning tools like Ansible, Salt, Puppet, Chef. It doesn't really need to be Python based. I think we need to choose the best tool for the right task, for the task. Finally, it's time to improve. Once you have everything in place, once you know what you are doing, once you have something that is going to cover your back. I think this is coming from the Boy Scouts. The idea is that you leave the code cleaner as you found it. And Python has brilliant tools for this. For instance, there's Pep8, which was renamed PyCodeStyle recently. There's Flake 8, which is a mixture of PyFlakes and PyCodeStyle, and Pylint and Radon. Let's see what's in there. And this is something I recently found. It's Radon. It's a tool for static analysis, and it tells you some metrics like number of lines of code and cyclomatic complexity, and some others which I haven't really grasped yet. So how does it work? Basically, with every nesting level you have in your code, you add a point to your score. So with every if, with every while, with every for, your score increases, and that makes it difficult to maintain. So at the end, the tool is going to give you a score from A to F. So A to C is something I would consider acceptable. It's okay to have. Anything above D could be a red flag for me, because it means it can be a source of headaches in the future. So this is more or less how the output looks like. You see, I have a couple of functions which have a really high, somewhat high score, 15 and 14. So that's something I need to really have a look into that. And there are some other parts of the code which are okay, 4 and 5. So I can more or less rest at home, because I know I've done a good job there. There's also Pylint. It's probably well known by many of you, but it's a tool that it's somehow difficult to configure, because if you don't configure it to your needs, it gives you a lot of false positives. It's going to tell you warnings about, for instance, you are catching too broad exceptions about variable or constant naming, too long lines, and so on. It's really useful, but sometimes using Pylint is a luxury, because in my case, for instance, I maintain a code base which still has quite a number of failures on this part, and it's too much. I cannot change everything overnight. I cannot put the checks on automated mode, because it's always going to fail. So it's the last part. Improve the people. Do test-driven development if possible. And if there is a single takeaway from this talk, it could be do code reviews. They are easy to do, especially with GitHub. I can tell you from experience, they help a lot, because each person in the team gets to review each other's code. So the newbies, the junior programmers, learn from experienced people how they do or how they solve problems. The experienced ones have a way to influence or to steer how the juniors produce their code. There's also the ego factor, because your reputation is always at stake, and if something looks wrong for you, it's probably gonna look wrong for your colleagues, and then it could be a shame. So you better do the things the right way the first time. It increases a lot the quality of software. There are many sources supporting this, and it's the right thing to do. It's just like washing your hands after going to the toilet, because it only takes a single person not doing it, and then things get filthy. And then, I don't know if there's time for questions, but I have 2 questions I would like you to ask me. One is how to attend a Python summit, a Swiss Python summit. And the second is, why can you buy Cornish pasties in Mexico? You can. Thanks a lot.
We've got about 5 minutes for questions, so if anyone has one, just raise your hand and I'll bring you the mic.
Please speak slowly. I'm having trouble with the British accent.
So you talked about the Boy Scout principle, leaving things cleaner, which is something I think is a great idea. But I did find when I was talking to people about that, interviewing programmers, that they were a lot more cagey about it than I expected, and it's partly because of that code review thing, and there are big differences. So how do you balance that tension between it's good to leave it better, but actually then you've got extra changes in there to look at that make it give you more information to deal with, bigger differences, rather than having the familiarity?
Well, there are some studies showing that the best point to improve software is when you write it.
right? If you introduce an artifact, a bug, or if you call it a time bomb, and that's a better definition, then it's more expensive to fix it when it's deployed 6 months down the road than just right after you checked it in. So I couldn't really sacrifice doing the code review just because of. I think if somebody's got a problem with the code reviews, that has to do more with the team internals rather than with the quality itself. Because I think it's doing reviews it's really worth the hassle, or it's a really good investment.
Anyone else?
First of all, thanks for the talk. Enjoyed it. I just wondered, do you have to handle code bases for Python 2 and Python 3? And if you do, how do you go about that?
No, sometimes it's difficult to port. I mean, in my case, I have a quite meaty code base. I would really love to move it to Python 3, but it's a luxury because it would take me like 2 months to do it.
So essentially you're saying it's just Python 2, you don't support both?
Whenever I write new stuff, I try to do it in Python 3 because I like it. I know it's a better language, but it's a trade-off. Sometimes you don't have the resources or the time to just do what you wish because, as I said, this is a business. In our case, this is a business. So we're not there just to have fun for programming. Sometimes we need to be productive and bring some money in. Thanks.
Hi, so how do you decide where to start within the code base with the improvements on the legacy code?
Well, last time I had to do some a takeover from code base. I had access to the previous maintainer. I wanted to kill him, but I didn't. So I took it the positive way, and then I asked him, please tell me which is the critical part. Which is the part I really need to understand. Because, there's the Pareto principle, which says that basically 20% of the code, or 20% of anything, is worth 80% of the value. So I could start with that piece of code, the most valuable, like the things that we cannot afford to break.
This is not a question, but for the guy asking on Python 3, I found the best way to do that is to do it gradually, as with probably anything. If using Pytest, you can set marks on some of your tests, say this part supports Python 3 or this part doesn't. And then you can maintain that in your CI and then gradually build up all very Python 3 support.
Sounds awesome. Thanks for the tip.
Anyone else?
This is an answer more than a question. If you're supporting a product, get really friendly with frontline support. They'll tell you where you need to refactor your code. You'll find out real fast.
I think there was one more.
Thanks for the talk. How do you deal with the social aspect of code refactoring? Like you want to touch a part of the code or remove it, and some of your colleagues is really attached to it because it's like his baby.
Yeah, I know what you mean. We in my team, I have a really good team. I really like them. I love them. The code belongs to everyone. It's not my code. It's like we see it like if you're in a boat and there is a leak, you cannot say the leak is not in my side, so I'm fine, because at the end everyone is gonna sink anyway. So it belongs to everyone. We're aware that we are not reviewing people. We are reviewing the code. So it's got nothing to do with the person, and it's about asking the right questions. It's not like, why you did this? It's not pointing fingers. It's more like, is there a reason for you to do this? Or have you considered maybe doing it the other way around also? It's more a people problem. Thank you.
Thank you very much. That was great. That's all the time we've got for.